In this video for section 6.2, we're going to calculate the standard deviation of a random variable. The symbol for standard deviation is this, it's called sigma. It's like a little O with a tail. And the formula is a little bit more complicated than the formula for the mean. And unfortunately, we are going to have to do this by hand. It's a few steps. So what you need to do first is subtract the mean from the data value, square the result, and multiply by the probability. And then you're going to repeat those three steps for each data value. When you're done with that, you add them all together. And finally, at the end, you take the square root of the number that you get to get the final answer. The value under the square root is called the variance. You may see that term pop up occasionally, but normally we focus on the standard deviation. So we're going to do this example. We calculated the mean number of cars per household earlier to be 1.4, and so now we're going to calculate the standard deviation. So what I need to do is take each data value and subtract the mean. So we're going to have 0 minus 1.4 for the first one, and so that's negative 1.4, and then I'm going to square that. And if I square that, I get 1.96, and then I multiply that by the probability of 0.142. And that equals 0.2782. And then I repeat the process for 1 minus 1.4, square the answer. Notice when you square the answer, you should always get something that is positive. Negative number squared is always a positive number. So all of these things that I'm adding up should be positive numbers. Multiply by 0.378. Obviously, you could do all these steps on a calculator. You can do them all at once. That usually works fine. My next data value is 2, so 2 minus 1.4 squared. And then multiply by the probability. And lastly, 3. 3 minus 1.4 squared. And multiply that by the probability. Once I have all of those calculated, I'm going to add them all together. And if I do that with these numbers, I should get 0.637. And then my last step is to take the square root of that number. So on my calculator, square root of 0.637, and then I'm going to have to round this number most likely. If I round to 3 decimal places, that would be 0.798. So that's my answer. A little bit of work. Now, number 2, this is our stock option problem. Day trader buys an option that will return $100 if the stock goes up today and lose $400 if it goes down. And there's a 75% chance that the stock will go up. And now we want to calculate the standard deviation using the expected value that we calculated earlier of negative $25. Now notice in the first step, you always need to subtract the mean from each data value, and so you need to calculate the mean in order to calculate the standard deviation. So let's remake our probability table here. We gain $100 with a probability of 0.75, and we lose $400 with a probability of 0.25. So each data value minus the mean. Now in this case, my mean is negative. So when I subtract it, it'll be 100 minus negative 25. So that will give me positive 125. And then when I square that, I get 15,625. Multiply it by the probability of, 0.75. And that equals 11,718.75. Now I need to do the second row. So this is going to be negative 400 minus negative 25, again, is going to change to plus. So that's negative 375 squared. Again, when I square a negative number, it should give me a positive number. And that is 140,625. And then I need to multiply by the probability for the second row of 0.25. And that's 35,156.25. So now I'm adding, kind of didn't have quite enough space to do this all in one row, which is how I usually like to do it, but I'm adding these two together. And if I do that, I get 46,875. And then lastly, I need to take the square root of that number. And when I take the square root, I get 216.51. Probably round to 2 digits after the decimal point because it's money. Now, what this standard deviation tells me is it's pretty big, especially in comparison to the expected value. Now, we already know that we don't want to do this option because our expected value is negative. But even if it was a positive 25, a standard deviation of $216 would tell me that if I think about taking mean minus standard deviation, if that value is negative, then I still might not want to do the option, because that tells me that there's a lot of variation and there's going to be a pretty good chance that I'm going to end up losing money, which obviously is what I do not want to do. I don't want to have negative dollars. So a pretty high standard deviation, again, tells me that there's a lot of variability, and that tells me that I might not want to do this option.